All right. So let's see. For the problem set of sections 5.2, the more difficult problems there, we have the inner product of two polynomials of degree 2 or less, defined as follows. So you multiply, so it looks like the regular dot product, but this time with the coefficients of the polynomial. So for example, for part A of problem number 23, we are given if p of x is 1 plus x squared and q of x is 1 minus x squared. We would find the inner product between these two by multiplying their corresponding coefficients. So for this, a0 is 1, a1 is 0 because there's no x term, and a2 is 1 because that's the coefficient of x squared. Similarly for this, b0 is 1, b1 is 0, b2 is negative 1. That's the coefficient of x squared there. So then we're going to apply this definition of the inner product, and we're going to say the product of 1 plus x squared with 1 minus x squared is going to be given by the scalar 1 times 1 plus 0 times 0 plus 1 times negative 1. So a2 times b2. So that gives me 1 minus 1. Since the inner product of these two is equal to 0, we conclude that p and q are orthogonal, so orthogonal polynomials. Now, the distance between these two polynomials, like any distance that we learned before, is the magnitude of p minus q. So we're going to first have to subtract the two polynomials, and then what we're going to do is we're going to find the inner product of p minus q with p minus q. So the square root of that inner product. So let's see. First of p minus q for our polynomials is 1 minus x squared minus 1 minus x squared, which is 0. So this is, anticlimactic a little bit. So then the inner product of 0 with itself is going to be 0 for this particular case. But let's make up a different polynomial. Let's say my p had a middle term, or both of them. So now I'm going to use some other numbers. So I'm going to use the same. I'm going to find the distance between p and q. If p of x is 1 plus x squared, and then q of x is 1 plus 2x squared. Let's just see what happens. So now a0 is 1, a1 is 1, a2 is 1, and b0 is 1. Well, we don't need these yet. So we're going to find p minus q now. So it's 1 plus x squared minus 1 minus 2x squared. That's your p minus q. And so x minus x squared is what p minus q is. So for this, we are going to use a0 equals 0 because there's no constant term, a1 equals 1, and a2 equals negative 1. That's the coefficient of x squared. So now we're going to find the inner product of this with itself and then take the square root of it. So we're going to say the distance between these p and q is going to be the square root of the product of x minus x squared with x minus x squared. So that's going to give me the square root of 0 times 0 plus 1 times 1 plus negative 1 times negative 1, right? So you're doing this here is the product of the polynomial with itself. So it turns out it's square root of 2, whatever units that is. Now, this problem is probably going to help you with problems like 21, or maybe just looking at how things are computed will help you understand better what inner products work like, how inner products work. So here we have a more unusual inner product. It's weighed heavily on the first component. The first product of first components is multiplied by 3. So we are asked in number 41 and 39 to find the angle between these two vectors. So of course we have to use the definition. So first we find the cosine of this angle theta. And the definition is I have to find first the inner product of u and v, the same as dot product, but this is defined differently, over the magnitude of u times the magnitude of v. But we have to use this different ways to measure the magnitude and the dot product. So I'm going to perform some calculations here. I need to figure out what u dotted with v, or multiplied inner product with v, will look like with this inner product definition here. So this is where I'm going to look to figure out what I'm computing. So the way the product is defined tells me to do 3, right, this 3, times u1, that's negative 4, times 0, plus u2, that's 3, times 5. So that means the inner product of u and v is 15. All right, so I'm going to put that up here. That's 15. Next, I want to find the magnitude of u. So to find the magnitude of u, I have to find a square root of the inner product of u with itself. So that means I have to find a square root of the inner product between u, which is here, with itself. So that means u1 and v1 will both be negative 4, and u2 and v2 will both be 3. So I'm going to start with a 3 and say this is 3 times u1, that's negative 4, times v1, that's negative 4 again, plus u2 times v2, that's 3 times 3, and it's 9. So let's see, 16 times 3 is, now let's see, the square root of 3 times 16 plus 9, it's about this much. So this is going to be about 7.55. All right, next we're going to compute the magnitude of v, and the magnitude of v is going to be, again, the square root of the product of v with itself. So of the product of 0, 5 with 0, 5. Okay, so that means I'm going to take the square root of 3 times 0 times 0 plus u2 times v2, that's 5 times 5, that's 25. So this will be square root of 25, which is exactly 5. So now I can go back here and say in the denominator I'm going to have the magnitude of u, which is 7.55, times the magnitude of v, which is 5. So now I have to find the inverse cosine of, let's see, 3. I'm reducing that 3 divided by 7.55, and it turns into 1.16. This is radians. If you go to mode, you see this is set up in radians. So if I want this in degrees, I have to switch it to degrees, and I'm going to have it computed again. So you can either list it in radians or degrees. I'm going to choose degrees because it's more, you can visualize it better. So it's about 66.6 degrees. So now problem 45 asks you to find the angle between two functions. So I'm going to choose to do number 46. So again, we have to compute, so to find the angle between these two functions, keep in mind that I have to compute the dot product of, the inner product of f and g, right? So for us, that means I have to plug this f and this g in here to find the inner product of f and g. So it's the antiderivative from -1 to 1 of 1 times x squared, which is x squared dx. And so that turns into x to the third over 3, evaluated from -1 to 1. So this is 1/3 minus -1/3, so it's 2/3. Also, I have to compute the magnitude of f, which is going to be the square root of the inner product of f with itself dx. So that is the square root of x. Sorry about that. Buckley, be good boy. So this is square root of 2, right? So the antiderivative of 1 is x. You plug in 1 and -1. So it's 1 minus -1 is 2. So this is square root of 2. The magnitude of g of x is going to be the square root -1 to 1 of x squared times x squared, which is x to the 4th. And so that's the square root of the antiderivative. So that's 1/5 x to the 5th, evaluated from -1 to 1. So that's square root of 2/5. Right? Because you plug in 1 minus -1. So then, to find the cosine of the angle between these, we're going to need the inner product of f and g divided by magnitude of f, magnitude of g. And so the cosine is going to be 2/3 over square root of 2 times square root of 2 over square root of 5, right? This is square root of 2 over square root of 5. So I'm going to simplify this just a little bit. This is 2/3 times square root of 5 over 2. These make a 2. So I have to take the inverse. So to find theta, I have to find the inverse cosine of square root of 5 over 3. So I'm going to go for the inverse cosine of the square root of 5 over 3. It doesn't like my domain. Yes, I typed it in wrong. And my parentheses should have ended after the 5 and then divided by 3, because otherwise I'm taking the inverse cosine of something more than 1. So this is approximately 41.8 degrees. So there, we found an angle between two functions. What do you think of that?